Hello again everyone, welcome back to ptet.chemistry channel. In this tutorial video, I'll continue the section B topical MCQ on section 9.1, which is essentially just a general periodicity. So this is mostly inorganic chemistry and something which is pretty dry for a lot of students, and I hope that through the rest of the topical MCQs on 9.1 that you have already watched, you will have seen that they are not that completely dry. In fact, there are a lot of very cool and interesting stuff that can relate to other parts of chemistry that you have learned. All right, so for instance, in this question, actually before I start, I should probably go through the options first. So there are 4 multiple choice options, and these are the last 10 questions of this section B MCQs. They are quite common in the Cambridge International A-levels. So option A refers to statement 1, 2 and 3 being relevant to whatever they're asking. B is 1 and 2, C is 2 and 3, and D is just 1 being relevant to whatever they're asking. All right, so which observations are correct when the information given is that you add water to that aluminium chloride? So aluminium chloride is AlCl3, and you make up 0.1 mole per dm cube of solution. So which observations are correct? We know it is acidic because AlCl3 undergo hydrolysis in water, so that AlCl bond gets broken, okay, and they get hydrolyzed by the presence of water. So if you write a complete balance equation, this is how you will write it. And you say you form Al2O3, so that means you need 2 of it, and they give you 6 of these, and you will have 3 of that. So they give you 6 hydrogen, 3 oxygen, 2 aluminium, and 6 chlorine. All right. So this reaction will be very exothermic because you're forming a very strong ionic bond. This is something you have covered in your O-level, GCSE or IGCSE electrolysis. So you know that these are very strong ionic bond between them. That's why you need very high temperature to electrolyze them. Okay, this one is a case study from your previous level of chemistry education. And this HCl is a gas. Okay, so it's a HCl molecule, all right, but of course it can dissolve in the water and give you hydrochloric acid. But the thing is, this reaction is so exothermic that this will have boiled off and you have seen it as a steamy white fumes. All right, so part of your observations. The thing that really happened in nature is that the aluminium surrounded by aqueous solutions, all right, is that you get 6 of those, and they have 3 plus charge. When you add water, these are the kind of equilibrium we can be thinking about. In fact, it's not an equilibrium, whereas the magnesium one is an equilibrium. This one goes to completion in terms of hydrolysis. So now you have Al3 plus and you have OH minus. So your net charge is 2 plus, and you have H3O plus because this is the proton donor. It donates the H plus from the H2O, and this is what you call the conjugate base. And conjugate base or conjugate acid is something that are stated specifically in the specification under acid and bases. So you can't say that you don't really know it, all right? So this is the base and it's the proton acceptor. You use the lone pair on the oxygen to take in a H plus and you become something called conjugate acid. Cut the long story short, the solution is acidic, and you will know that that is around pH 2 or pH 3, strongly acidic. The reaction is, however, not endothermic. It is exothermic and not endothermic. 2 is correct, 1 is wrong. You can jump straight to option C. In fact, that is what is correct as well, as I've just shown you. And you also contain a bit of this as well as a result of this being hydrolyzed to give you the H plus in solution. All right, and so on and so forth. Moving on to the next questions, this is all about the chlorides of the third period again. So which statements are correct? So we start from sodium chloride to magnesium chloride to AlCl3. If you have NaCl in water, they don't get hydrolyzed, so not hydrolyzed. But both of these get hydrolyzed by water. So what actually happened is your Na is just surrounded by 6H2O and they are not hydrolyzed. But why does the MgCl2, why does the MgCl2 and AlCl3 get hydrolyzed? As you would have known that the ionic radius increases in that order. All right, so it decreases across a period. These are part of a periodicity, as well as part of the atomic radii trend that you have picked up in topic 2. Okay, that is in terms of atomic structure, effective nuclear charge, and so on and so forth. Because these are much, they get smaller, not bigger. They get smaller. So these are smaller cation, and because they are smaller cations, they are more polarizing. Okay, they are more polarizing. They exert a greater degree of covalency on the magnesium, on the anion, sorry, and therefore easier to break the OH. Okay, more polarizing on the OH of H2O. Remember that in the previous question, so what you have essentially is in the presence of water, your cation is going to be surrounded by water. The smaller you are, the more polarizing you are on the water, and therefore it's easier to break the OH bond, and therefore the the extent of hydrolysis increases in that way. All right, so this is more hydrolyzed than this, therefore your pH remains 7, which is not hydrolyzed. This is only partial ionization or partial hydrolysis, which means the equation that I showed in the previous question, it would be an equilibrium. That's why you get a weak acid for MgCl2. All right, but LCl3 is pH 2, pH 3, strongly acidic. That is perfectly fine. All right, so that is your 6.5 pH. That is your pH 2 or pH 3, and that it should be pH 7, and it's not alkaline. All right. Oops, probably I don't want to do that. So it's not alkaline, so it's 1 and 2 being correct, 3 is wrong, so that's option B. In this next question, so we're given, again, these are all chlorides of the third period. So it's very nice in topical MCQs that everything's related to what you have learned, but then you got to realize that in an actual paper you do have a combination of topics as well. So even though I do like to go through topical MCQs, at some point you do have to go through a full paper to see the full range of stuff being asked, rather than just being good in one thing and not other things. All right, so compound X does not conduct electricity when in a liquid state. Okay, so this is not ionic compound. All right, because ionic compound would have free ions when they are molten, when they become liquid, whereas this one does not conduct when it's molten, therefore there are no free ions, therefore not ionic compound. If not ionic compound, I can cross out that because there is ionic compound, and you will get Mg2 plus and Cl minus when you melt it, and it will conduct electricity when in a liquid state. So 2 and 3 are simple molecular. In fact, SiCl4 is a tetrahedral molecule due to the presence of 4 bond pair and 0 lone pair. So your valence shell electron pair repulsion theory says that the 4 bond pair will repel equally, and you get tetrahedral geometry, which is 109 or 109.5. Your PCl3 will have the same geometry as ammonia because phosphorus is just below nitrogen. It's got 5 outer shell electrons. Use 3 for bonding here, so it still has 1 lone pair there, and a lone pair of electrons and bond pair repel more than bond pair, giving you trigonal pyramidal geometry. So that's just 107 degree. This question is not about shape of molecule, however. It's about the second bit here. When added to water, you produce a solution that readily conducts electricity. Okay, when you add it to water, you can produce a solution that is ionic, or at least that's got free electrons or something. Okay, we know both of these get hydrolyzed in water to acidic solution, because when you get acidic solution, you get H plus ions, and if you get H plus ions, you get free ions in the solutions, therefore they can readily conduct electricity. But just by knowing that 1 is wrong, there is no other option apart from 2 and 3 are correct that are suitable from the options given. So we would have known that anyway, just from the first bit of information here. All right, so 2 and 3 is option C, and that's it really. Okay, so in theory paper, you'll be expected to know how to write the balance equation to show the hydrolysis of these to form SiO2 and HCl, and this one is phosphorus plus 3. So I'll just highlight these because you started with phosphorus plus 3. when you add water to it, you would get the acid, which is phosphorus plus 3, and your anion is PO3, 3 minus. This is called phosphite and not PO4, 3 minus. So your acid is H3PO3 plus HCl, which I can now balance. There's 3, so there's 6 hydrogen, 3 there and 3 there, 3 chlorine, 1 phosphorus and 3 oxygen. Okay, if you try to balance it with H3PO4, H3PO4 is PO4 3 minus anion, and that one is minus 3 equal to phosphorus plus 4 times minus 2, phosphorus minus 3 plus 8, that is phosphorus plus 5. That is what you get when you reacted PCl5 with water. This is not a redox, these are simple hydrolysis. It's an acid-base reaction. Well, it's hydrolysis, not an acid-base reaction. This is a hydrolysis, not a redox. Okay, so you are not going to form PO4 3 minus from the PCl3, which is phosphorus plus 3. And a lot of students are not aware of these things when these are all stated in the polyatomic ions that you should have known from your GCSE, IGCSE, or O-level chemistry. In this next question, so that we are told that nitrogen and phosphorus are both in group 5. This type of Roman numeral is just an older way of representing. Okay, it's not older, it's another way, it's an alternative to presenting the name of the groups. I find it strange that the GCSE and IGCSE and O-level chemistry, they still use this Roman numeral, but when you come to A-levels, we have swapped to, so this was from 2012. I think a couple of years ago, Cambridge International has swapped using this Roman numeral with this kind of just numerical value as stated in your periodic table. Alright, so phosphorus forms a chloride. So here is PCl5, so there's phosphorus plus 5. Why is it not possible to form NCl5? Well, if you think about phosphorus, you have 1s2, 2s2, 2p6. So I'm looking at the atom, 3s2 and 3p6. When you think about nitrogen, which is above it, it's got 1s2, 2s2, and 2p3. These are of the atom. Okay, so your outermost shell is n equal to 2, your outermost shell is n equal to 3, and actually you have 3d orbital because you're in n equal to 3, and the energy are not so different. So you can actually use the 3d for bonding as well. And in the d orbital, in the 3d orbitals, you have 5 of them. Okay, that means they can accommodate 2, 2, 2, 2, 2. You can accommodate extra 10 electrons, whereas you can't do that with the second shell element because the 3d are so high up in energy compared to n equal to 2, and you don't get 2d at all. You only get up to 2p. So 2 electrons plus 6 maximum in the p, there is 8 electron maximum. Okay, so number 2 is definitely wrong, because when you say nitrogen cannot have oxidation state plus 5, think about contradiction. NO3 minus. Nitrogen plus 3 times minus 2 is minus 1. Nitrogen is plus 5 there. You know nitrates. All nitrates are soluble. You got a lot of compounds that have nitrates. Nitrogen is plus 5. But that does not mean that nitrogen have more than an electron in the outer shell. This is just the oxidation number. 2 is definitely incorrect. Only 1 is correct. And number 1 is basically what I just said about the maximum number of electrons you can accommodate in the second shell versus the maximum number of electrons you can accommodate in the third shell when you think about the presence of the 3d orbital, which is not filled in the phosphorus electronic configuration. Okay, in fact, I've got the wrong electronic configuration. So phosphorus is in group 15, so it's 2 plus 3, which is 5, 2 plus 3, which is 5. They should have similar electronic configurations, except the outermost shell are different. All right, so always check these kind of little things. In these next questions, this is the last of this 5 question series. Which chlorides of period 3 elements will form a neutral solution? There's only one. NaCl, because that is the only period 3 chlorides not hydrolyzed. The rest of them, they undergo hydrolysis to some various extent. So we are just looking at NaCl and not any of that, all right? So the answer is very obviously just 1 there. The Al2Cl6 is a dimeric version of AlCl3. So when you write the balance equation, you can really just write Al2Cl6 plus H2O. It will give you the same product, which is Al2O3 plus HCl. I get 6 HCl because I get 6 Cl, and the 2 is already balanced there. I have 6 hydrogen, so there's 3 there. And I think earlier I remind you that PCl3 dissolve in water to give you H3PO3. But this is phosphorus plus 5 because this is PCl5. You will get phosphorus plus 5, which is PO4 3 minus. This is called phosphate. These are your simple polyatomic ion. Polyatomic because they contain more than one atom. So your acid combination with H+, when you have H+, your lowest common multiple between 1 and 3 is 3. So you need 3 of these to get up to plus 3. You need 1 of these to go up to minus 3. So it's H3PO4. And of course, we also get HCl to balance the equation. 5 HCl because of 5 chlorine. And 4 oxygen, so 4 there. So there's 8 hydrogen. 3 plus 5 hydrogen is 8 hydrogen. Okay. So, I don't know, I mean, a lot of students will have struggled with this. The other one being SO2, SO3, giving you H2SO3 and H2SO4 respectively. Alright, so something you have seen, something you have learned, but not something you might have understood previously. So this is the end of this 5-question tutorial series on section 9.1, general periodicity. Don't forget to click the button on the bottom right, subscribe to the channel, share the channel with more friends, your juniors, your seniors from school, your various chat group with friends or relative, and hopefully can help more people. All right, thank you for watching. See you in the next video.